Okay, so now that we have learned about solving quadratics, the last little piece we need to cover about quadratics is problem solving with quadratics. So we're talking about word problems, application problems, different ways of thinking about how the solutions help us. So we're just going to do 2 examples today, okay? They're each going to be a word problem, and then we're going to be done. Example 1. The length of one side of a shoebox is 5 centimeters more than triple the width. The base of the shoebox has an area of 49 centimeters squared. Write an equation to represent the situation, then find the length of the shoebox. All right, so in this problem, we are representing area. Area is one way that quadratics are related because it's multiplying 2 things together, and that gives us squared values. Okay, our goal here is to figure out how to write the equation and then how to solve for what we need from that equation. So the length of one side of a shoebox, okay? So what I like to do on these problems is to draw a picture. So I'm going to draw a box. All right, we're only talking about length and width, so it doesn't need to be 3-dimensional. So shoebox, 5 centimeters more than triple the width. Well, 5 centimeters more, that's the same mathematically as plus 5, okay? Triple the width, triple. What is that the same mathematically? Now, if we talk about double, we're talking about times 2. Triple is times 3, so that's being multiplied by 3. So it says the length of one side of the shoebox is 5 centimeters more than triple the width. So I'm talking about width, so that would be W, and I need to be 5 centimeters more, but it says triple the width, so that would be 3W. So that's what my length is equal to. Now notice I used W for width, so I'm going to put a W on the width. Okay, so now we have our width, and our length is 5 centimeters more than triple the width. So that's how I would use the words to create my picture. Now it gives me the information. The base of the shoebox has an area of 49 centimeters. Area of 49 centimeters. So I'm going to say the area equals 49 centimeters. How do you find the area of a rectangle? Yeah, length times width. So area of a rectangle equals just length times width. Okay, my length is represented here. My width is here. So I'm going to do area equals 3W plus 5. That's my length times my width, which is W. Okay, now I know what the area is, so let's plug in that 49 for my A. All right, this is looking like an equation, but it doesn't look like a quadratic right now, does it? Okay, we can actually turn it into a quadratic by multiplying it out. So I'm going to actually change the way this is written. I'm just changing the order because we're more used to multiplying this way. Right? So I just switched these so that we can distribute that W. So W times 3W is 3W squared. W times 5 is 5W. And it's equal to 49. Okay, now we have a quadratic we can solve. So we're back to what we were learning before. I have to first get it equal to 0. How do I get this equation equal to 0? I'm going to subtract 49. Minus 49 minus 49. That's 0. There are no like terms over here. Okay, now we could either graph, factor, or use quadratic formula to solve. Okay, graphing doesn't always give me very exact values. I could look to try to factor, but these numbers are kind of larger and I don't want to take the time. So for this problem, I would think that the best method would go straight to quadratic formula. So let's identify A, B, and C. A is 3, B is 5, C is negative 49. Okay, and I'm going to plug it into my formula. X equals negative B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times my A. Okay, now I'm going to use a calculator. Okay, in this case I'm going to use the Desmos calculator, and I'm going to evaluate the discriminant. 5 squared minus 4 times 3 times negative 49. All right? 5 squared minus 4 times 3 times negative 49. This is my discriminant, remember? That's going to help me simplify. So let me go to my Desmos, and I'm just going to type that in. Five squared, okay, minus 4 times 3 times negative 49. And that gives me 613. So I'm going to go back. This equals 613. And that's what I'm going to plug in right here. All right, so my discriminant is underneath the radical. So let's plug that in. I'm going to simplify these other two pieces. A negative times a positive is a negative, so that gives me negative 5. Plus or minus the square root of 613. 2 times 3 is 6. All right, we are almost done. Let's get our two answers and figure out which one makes sense to solve our problem. So we have negative 5 plus the square root of 613. Oops. Then divided by 6. And then negative 5 minus the square root of 613 divided by 6. And I'm just going to use my calculator on Desmos to do that. You can use your graphing calculator if you'd like. So negative 5 plus the square root of 613. The nice thing about Desmos is you can actually type all this in at the same time as long as you use parentheses. So negative 5 plus the square root of 613. Oops. Let me do that. There we go. And then if I press the division button here, see how it put all of this in the numerator? So as long as your whole numerator is on top of the fraction, then you're good. Otherwise, you need to do it in two separate steps. Okay, we're going to round to the hundredths. Anytime we're dealing with real-world problems, decimals are usually more useful than fractions. Okay, so 3.29 is our first one. So this was 3.29. And let's see what the other one is. So also the nice thing about Desmos is I can go straight up here. Everything stays the same except for my plus sign. I can erase it and turn it into a subtraction sign, and it automatically does the math for me. Negative 4.9, that 5 rounds up to a 6, so negative 4.96. Okay, so which one do you think is the x that we're going to use for this problem? Remember, we're talking about a length and a width of a shoebox. Which solution makes more sense? The positive one. We can't have negative width or length, so we know that this one doesn't apply. Now the question is x my width or my length? Well, let's see. If I go with my problem, I realize that I've actually changed my variable. My original variable was w. So all of these x's should have been w's. So if they're w, then that means that this is the answer for my width. My width is 3.29 centimeters. Okay, so I can plug that in here, 3.29. Now, is that what my question was? Write an equation to represent the situation. Okay, we did that here. Then find the length of the shoebox. So I don't want width, I want length. Well, that's okay, I have an equation here. It's just triple the width plus 5 more centimeters, right? 3 times the width, which is 3.29, plus 5. So I'm going to come down here and find my length. 3 times my width plus 5. Well, what was my width? My width was 3.29. Okay, so I'm going to go to my calculator, do 3 times 3.29 plus 5. So 3, let's try that again. 3 times 3.29 plus 5. And that gives me 14.87. Okay, now we are rounding here, but we should be able to check our work. If this length and width is correct, then my area should be approximately 49 centimeters. And that would be centimeters squared. Sorry about that. Okay, so let's do 3.29 times 14.87. .29 times 14.87. 48.9. I think that's pretty good. The reason it's not exact is because we had to round earlier in our problem. Okay, and that is how you would solve an area problem using quadratic equations. So there is our answer. Okay, example 2 is done. Or I'm sorry, example 1 is done. Let's do example 2 and we will be finished. So one way that quadratics are related to problems is through area. The other way is through gravity. Okay, so Jane decides to throw her shoe from her treehouse at a height of 6 feet to see how long it would take to hit the ground. The path of the shoe is modeled by the quadratic equation here, where h is the height of the shoe in feet, and t represents the time that it has passed since it was thrown in seconds. How many seconds did it take for the shoe to hit the ground? So we've got to think, when it hits the ground, what part of my quadratic is that? Sometimes a helpful way to do that is to sketch a graph, okay? We know our y-intercept is 6. We know it's opening down because it's negative in front. So this doesn't have to be perfect, okay? I'm just going to sketch a graph. It's a shoe being thrown. So y-intercept is 6. It's opening down. It probably looks something like this, right? So when on this graph is it hitting the ground? Well, it's hitting the ground when my height is 0. And that would be my x-intercept here. Well, when I'm solving for x-intercepts, that means that I'm solving my quadratic equation. So it hits the ground. So we want to know at what time is that. Time is t, that's representing our x here, so we're solving for x when h is 0. So let's plug in 0 for h. And now we want to solve our quadratic. It looks like we have a GCF here, so let's pull that out and we'll see if we can factor. Let's see, I know they're all divisible by 2. Are they divisible by anything higher? I don't think so. Let's check. So that's going to be 2 times negative 8. Oh, sorry, let's make that a negative 2. Since our leading term is negative. Negative 2, so that's going to be 8t squared plus minus 24t minus 3. Okay, they don't have anything else in common. The numbers are larger than what I'd want to work with factoring, so we're going to use quadratic formula here. A is equal to 8, B is equal to negative 24, C is equal to negative 3. I'm going to go through and plug it in. Negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So same process as before. Once you know the problem solving piece, then you can just decide how you want to solve your quadratic, okay? You just got to figure out how to set up your problem. That's the most difficult part here. I'm going to evaluate my discriminant. I'm going to put this in the calculator. So negative 24 squared minus 4 times 8 times negative 3. All right, I'm going to come up here. Negative 24 squared times 8 times 3. And that gives me 480. So this is going to be double negative. Negative times a negative is a positive. So 24 plus or minus the square root of 480 divided by 16. And I'm going to find my two answers. So 24 plus the square root of 480 divided by 16. And then 24 minus the square root of 480 divided by 16. Here we go. We're almost done. If I can get my cursor to work. 24 plus the square root of 480 divided by 16. So that gives me 2.89. Okay, and then let's go ahead and do the minus while we're here. 0.13. So 2.89. 0.13. So which one makes sense to my problem? Well, let's look at our graph. Does it make more sense to be here when it lands or 2.83 further out? All right? So it makes more sense to be the later one when the shoe is landing. If it was so close to the time, all right, that's probably where it started. So 2.89 seconds is my answer.